Good afternoon. Thank you for being here in such high numbers, which I didn't even expect. But we have a great name here. Dirk Helbing will present some of his work. And of course, he is a person who doesn't need to be introduced. He is the initiator of the Future ICT, candidate for flagship project, the European flagship project, which unfortunately was not successful, but almost successful. And I still regret that it was not successful. And he's working in societal areas, in technical areas, big data, for instance, but also in communications, using new communication means to support the digital citizen. That's exactly the topic of this event today. I called it the Minisymposium because we have two back-to-back talks about similar topics, and I'm looking forward to hearing both of them. The second speaker will be Panos Antoniadis. He's sitting here, and he will give his talk afterwards. So thank you very much for being here, and we are looking forward to hearing you.
Yeah, thank you very much for the kind invitation, and good afternoon, everyone. So I'm very pleased to talk about the digital society and the planetary nervous system we are working on. And actually, there are two team members who joined in today, which is Evangelos on the one hand and Stefano on the other hand. So welcome to talk to them too. The problems of our world are complex, and this includes climate change, conflict and war, financial crisis, social unrest resulting from this, the digital revolution, and cybercrime also related to this, and finally, cyber war. These are global problems today, and currently there is no solution. We certainly need to prepare ourselves better for the digital revolution to come. So I've already shown you this exponential increase in computer power, and what it implies that in about 10 years' time, computers might reach brain power. And that's one of the reasons why the Human Brain Project in Lausanne was funded. Now, in fact, we know that computers have beaten the best chess players already many years ago. And IBM Watson can do even more. Watson can beat even the most sophisticated players in game shows, and can also advise people in customer hotlines, can advise even doctors. And so we are now exposed to a big data tsunami, and that has implications because it's going to transform many businesses, but also institutions of our society. So let's look into this. The way we educate is changing. Just think of MOOCs. We're certainly heading towards personalized education. Research is changing because suddenly there's a fourth pillar of science, big data analytics. The way we move, so we'll soon have self-driving cars. The way we transport goods through drones, for example. The way we go shopping, already since a long time. And also the way we produce. So now we can use 3D printers and produce at home. The health system will change through personalized medicine. Politics will change through more citizen engagement. And the economy is changing as well with the makers community, the sharing economy, co-producing consumers, also known as prosumers. The financial business too is changing. It used to be the domain of bankers, but now it's increasingly replaced by algorithmic trading, PayPal, Bitcoins, Google Wallet, whatever. Insurance business is changing. Just think of all these derivatives. And finally, war is changing too, with cyber war. I mean, everything is changing. We need to be aware of this, you know. And in fact, even though Kodak is the company that owns the most digital camera patents, they went bankrupt because they couldn't transform themselves quickly enough into a digital company. This is how we produce cars today. Do you see any worker? No. Actually, this can be done by robots. And so it's no wonder that some cities look like this. You know, the classical automobile factory towns like Detroit are in a very bad condition. This is one of the side effects of this digital revolution. And in fact, if we look into historical numbers like employment numbers, then we can see that 1815, about 70% of people have still been working in agriculture. So that was the agricultural society, but then the steam engine was invented and the industrial society came up, a new sector of the economy that transformed the society, and eventually the service society came up, the green curve here, with public schools. And now what's happening is that there will be a fourth sector of the economy, the digital sector. That's the sector of information and knowledge production, represented by the red curve. Now, the problem is that these transitions usually are not smooth. And that's why we need to prepare for them, to make them as smooth as possible. In this time period, there were a lot of bad things happening. In fact, like revolutions, wars, mass unemployment as a trigger of these things. And we certainly don't want wars and revolutions to happen. We want to have a smooth transition into this new digital society to come. The challenge is that 50% of the jobs we have today in the industrial and service sector will be lost in the next 10, 20 years, according to a study of Oxford University and other studies. So many experts expect this drop by 50%. Now look into the numbers. Okay, you cannot lose many jobs in the agricultural sector in most countries, but in industry we would go down to less than 10% jobs. In the service sector we would go down to less than 30% jobs, which means that the sum of jobs in the agricultural, in the industrial, and the service sector is less than 50%. And in other words, we need to produce 50% new jobs. And half of the jobs need to be newly generated in the digital economy. And in fact, I believe we are already seeing this transformation happen. And that's the reason why we have these huge numbers of youth unemployment. In some countries, it's more than 50%. So we're in the middle of this. How can we address all these problems? Major problems, complex problems. Certainly, if we do nothing, if we go on as we have done in the past, it may end in disaster. And the old approach was, we go to the library, we study all these books, it takes time, we employ PhD students and postdocs, and it takes 3, 4, 5 years to do a project, and then eventually we have the answers to the question. That's a pretty slow process. And the question is, do we have enough time? And once we came up with our solutions, we wrote new books, and eventually that was put into laws, like we had even more books, and then we had to create enforcement institutions so these laws would be applied, and finally managers and everyone else complained about over-regulation, and the side effect is that all the industrial countries have huge debt levels because actually we cannot pay for the system any longer. Yeah, I don't think this is going to work forever, so we really have to think about a new approach, and in fact, I believe this is already happening to some extent without most people having noticed this. So this is the big data approach. Now there's huge masses of data about every human activity on Earth. And in fact, what politicians and other decision makers do or would like to do is what we actually do every day, like go to the internet, ask a question, get a result within seconds. Now, push the button, have an answer. So this is kind of the big data spirit that would enable a big government approach, and this is what happens in just 60 seconds, about 700,000 Google queries, about 500,000 Facebook comments. This is just mind-boggling. And then, of course, we have location data, shopping data, you name it, everything into one basket, and then this is the new resource. Data is the new oil, people say. And that's good for countries that don't have other resources. In fact, McKinsey estimates that there is a potential for 3 to 5 trillion additional dollars that we could make on open data alone. That's a hell lot of money, We should make sure that we get a share of this money, but in order to get there, we need to learn how to drill this data. We have to create these data sources, and we have to distill this data in order to transform it into useful information and actionable knowledge. And in fact, with big data, we can do quite a few interesting things. We can craft instruments to explore the world. We can create compasses for decision makers, compasses that would not only measure GDP per capita, compasses that would be much more fine-grained, time-dependent, would be able to measure things that we can't see, like social capital, for example, reputation, trust, solidarity, and happiness. We could understand the spreading of international tension. We could prepare for imports of Ebola, that means to protect us better against disease spreading. We could actually try to predict the spreading. And in fact, what we did is we were taking data from the World Health Organization, and if you display them in space and time, then it turns out that it looks like a great chaos. It doesn't seem to make any sense how these diseases spread. And so as a result, actually you find these widely scattered data clouds. You cannot really do something useful with it if you don't combine that with another data set, because the reason for this chaos is that people are traveling a lot by airplanes. So if we use air passenger data and use a mathematical model to define an effective distance, then suddenly the very same disease spreading looks like this. Suddenly we have circular spreading patterns. And it makes a lot of sense. This is what we expected in the first place. This is how diseases spread at the times of the Great Plague, when there were no airplanes. So now we can understand the spreading process, we can identify the likely source of the disease, and we can also say, these are the cities that are most likely the next one to have the flu wave. And those are the cities that are after this. So we can prepare much better. We can also quantify scientific productivity, impact, the flow of ideas, the production and consumption of inventions, and even scientific concepts such as physics means can be measured from all these data, and we can identify these trends over time. Actually, never seen such a clear picture of physics, even though I was a physicist. And we can also map cultural spreading over an amazing time period of 2,000 years just by using birth death data. So we can see how culture really came towards the east coast of the United States when Columbus discovered the country, and then eventually it spread to the west coast. So some of this excites people, and so the question is big data maybe a universal tool to understand and govern the world? I mean, this is not the question that I'm asking. I think this is a question that some strategic thinkers have been asking for quite some time. So as we produce more data about the world and collect it, can we know everything? And even if that was just a dream, you know, we should kind of make a short philosophical round of thinking about this, because certainly, you know, government would like to have such a tool. They would like to build a crystal ball that tells them what's going on in the world, in every single place right now. And they would love to predict the future of the world if that was possible. So assume somebody had all this information. Could that person govern the world in the optimum way? Like a wise king, a benevolent dictator? Could that person create the perfect world? Would technology enable that person? And in fact, it's a building on an old idea, state as a powerful actor that would make sure that people behave in a civilized way and that people coordinate to the benefit of everyone. So there's a lot of top-down thinking and coordination behind this. But of course, most people believe that the world is not a clockwork that changes in a deterministic way. And so how would you keep it on track? Well, people often say knowledge is power. So if you know everything, if you're all knowledgeable, would you be all powerful, you know, almighty? And it's again a theoretical question, and you know, some people might dream about it. So it's better if we think it through. So certainly, if we wanted to keep the world on course, as we figured it out to be the optimal course, we would have to be able to manipulate people's thinking and choices. I'm not advertising this as a positive future, and we're just thinking this through for the sake of the argument, right? And in fact, it turns out that we are influenced by personalized information already. Increasing fraction of the day. If you Google, you get a personalized answer. If you go shopping at Amazon, you get personalized recommendations. If you book your trip, your hotel, if you use an app to find somebody to go out in the evening and have some fun, there is technology that recommends you what to do. And people do more and more what's recommended to them. So are we already steered by the Silicon Valley? Is this already true? And maybe it's good. If it's good for the world and for everyone, if that produces a favorable life, you know, why not? Unfortunately, the problem is that this kind of influence on our decision-making undermines the wisdom of crowds. And that could actually unintentionally produce bad solutions. But besides that, fortunately or unfortunately, as you may think about it, the crystal ball and this possibility to influence people's decision often fails. And it will always fail for a number of reasons. First of all, in complex dynamical systems, there is a problem of predictability. We know that from the weather forecast. And even if we would collect more and more data about local weather conditions, have a more and more fine-grained measurement grid. It would not produce a perfect forecast for a year or 10 years, never ever. For a simple reason, the physics behind this is the physics of turbulence. And it's similar to a certain extent to the physics of deterministic chaos. And we know from there that even though these equations may be deterministic, the slightest change in the initial conditions, unmeasurably small, could eventually produce large deviation. This is called the butterfly effect, and it's very difficult to imagine, but this is a physical fact. There are other problems, such as big data analytics discovers patterns, but not always are these patterns really meaningful. It's like we see certain patterns in the sky, which are actually not there. And take this spurious correlation here. It says number of killers increases with chocolate consumption. So now, if this was a true correlation, a causality, we would be living very dangerously here in Switzerland. There is another problem, classification. You want to distinguish between good and bad risks, but usually there is not a clear separation. No, there are some points that could be on this side of the line or on that side of the line. So we don't know, are they good or bad? So as a result, we would make mistakes of first and second kinds, false alarms, and we would also unintentionally discriminate people. And we may not want to do this. So, big data is not a universal tool. It's not a perfect tool either. But it certainly allows us to do evidence-based decision-making. We can reach improvements. And so, we look at these curves, then we see that processing power, blue curve, increases exponentially. It doubles every 18 months. The data volume doubles even faster every 12 months, the green line. We are certainly heading from an age of too little data to take good decisions into an age of big data where we can take evidence-based decisions. But we see that the gap between the data in the world and the data we can process is opening up more and more. That means a smaller and smaller percentage of all data can ever be processed. That produces dark data that will never be looked at. And the question is, what are the implications for this? Well, it produces a flashlight effect. We pay attention to certain things, we don't see other things. And this can be quite dangerous if we believe big data would tell us what's important. In fact, it didn't tell us that there would be a financial crisis. It didn't warn us of the Arab Spring. It didn't warn us of the crisis in Ukraine. It didn't warn us early enough of Ebola. No. The problem was we were paying attention to other things. While we were fighting terrorism in the aftermath of September 11, the financial crisis came up. While we were fighting the financial crisis, the next problem came up. This is how it works. And so, that's not a perfect tool. And moreover, we see that systemic complexity is increasing even faster. So all the data in the world will increasingly less reflect this complexity that we are creating. We will be increasingly less able to optimize this world in real time. And that implies a loss of top-down control. this is shocking, you know. You have ever better tools, ever more data, and you're losing control. How can this be possible? Well, it relates to the networking in the world. You know, as we network the world, there are kind of combinatorial new possibilities, again, to network and create ever more complex systems. And that creates a factorial function, and that increases faster than exponential. So we have to look into complex dynamical systems. Now for this, we need to distinguish between complicated and complex. A car is a complicated system. Yeah? It consists of many parts, but they're fixed in a certain place, and the car is very well controllable. Yeah? It's not a complex system. A complex system is also made up of many system components, but they interact dynamically. They try to adjust each other to other system components in a dynamic way. And then self-organization happens, like these traffic jams that occur. Because the eigendynamics of the system dominates influences from the outside. And that creates emergent properties, it means new properties of the system, and so on. Fortunately, there is a science for this. It's called complexity science. And one of the reasons for things going wrong in the world is unstable dynamics. So let's take this example. It shouldn't be difficult to drive in a circle, right? I think everyone with a driver's license should be able to do this. But in fact, what happens after some time, traffic breaks down. So there is a phantom traffic jam, a spontaneous traffic jam, and once that has formed, it stays there. You don't get rid of it anymore. Now, why is this happening? If you would ask drivers, they would probably say, that was a stupid driver in front of me who didn't know how to drive a car. Now, there is mathematics of these kind of phenomena. It tells us that above a certain critical density, that means if the distances drop below a certain critical distance, then traffic flow becomes unstable, and the slightest variation actually is amplified. So the next driver responds with a delay, and to compensate for this delay, he has to tip the brake a little bit stronger. The next one even stronger and stronger. So it creates a chain reaction. As a result of that chain reaction, traffic is stopped, although nobody wants this to happen. Unfortunately, this example is paradigmatic for unstable, dynamical, complex systems. And in these systems, no matter how good your technology, how much data you have, and given the very best intentions of everyone, the system will get out of control sooner or later because of this instability. So you shouldn't build such kind of systems, you shouldn't operate systems in an unstable regime. There are many other examples. You know, under normal conditions, pedestrians self-organize quite nicely. So it's a very efficient counterflow, but in other situations, if the density is too high, crowd disasters would happen, as we've seen it many times. Now, in networks, the situation becomes even more sophisticated. A single failure can actually trigger other failures in the system around it, and that could again damage the system in such a way that the damage would propagate. So there would be a cascade effect. And damage would get larger and larger and larger. This can be a slow process. This is going on in case of the financial crisis since 2008, in the case of September 11 since 2001. These cascades haven't stopped yet after so many years. So if you have such a system with critical mass, critical density, a single local perturbation can mess up your entire system. Now think of this system as a model for the world. If we have connected it too much. This is an experiment that's often done to illustrate how a nuclear power station works. It's nuclear chain reactions if you are above the critical mass. And we do know that these kind of processes are controllable in principle, but it's difficult to control them, right? Chernobyl, Fukushima, they tell us sometimes this is getting out of hand. What about real-life systems? Are we faced with these kinds of problems in our real socio-economic world? Unfortunately, yes. This is the bankruptcy cascade that happened after the collapse of Lehman Brothers. It looks pretty much the same as the previous video. Of course, details are different. We do have such cascades, and these cascades can have global size. And that is concerning, and that's why the world needs you to fix these systems, to build them in a better way. If we extend the stop-and-go traffic to the economy, look at mature flow supplies in a global supply chains, then we can understand booms and recessions like stop-and-go waves, this time in our economy. Now I will show you how to overcome stop-and-go waves in traffic flows. The question, can we build systems to overcome recessions? But we don't only have networks, we also have networks of networks, so that creates complex interdependencies, and in fact, now all the systems depend on each other, and that makes systems even more vulnerable. And the World Economic Forum updates their report every year, and we find, and they find actually, that social, economic, and political instabilities are the biggest problems these days. Now, what can we do in order to manage these complex dynamical systems? Well, you often would say, okay, we need to control them. And unfortunately, this is often counterproductive, because if you want to get there, your system would get somewhere else. If you want to change the system in the beginning, nothing happens. And then you think, okay, we have to try harder, and nothing happens, and try even harder, and then suddenly, oops, the system does something completely unexpected. There is a phase transition and a tipping point, and the previous order just breaks, and there is some chaos then, and eventually there is a new kind of order, but in many cases we don't know which one. Not necessarily the one we wanted. And so in these kind of systems, actually, applying too much force is really counterproductive. Interestingly enough, there have been many technological improvements in airplanes, but the one measure that really increased airplane safety the most was to replace the hierarchical culture in the cockpit by a culture where the co-pilot was encouraged to question the actions of the pilot. Are you really sure this is the right thing to do? This is what improved safety the most. Now, I'm personally convinced that we need to have a completely new approach. We cannot solve the problems with the same kind of thinking that created them, said Albert Einstein. If we could do it, we would long have solved all these problems. So we need to start to think about these problems in new ways. if we can't predict the future, we should have a resilient society, or a society that can absorb shocks, that can adapt to whatever happens. And the question is our society built in this way? Well, we know certain things about resilient systems. And coming back to this Gordian knot that I showed in the very beginning, representing complexity, many years back, Alexander the Great was faced with this problem to solve the Gordian knot. He took this sword and cut it. Now, can we learn something from it? Well, in fact, in these complex networks, we need to have engineered breaking points to stop cascades. Everyone has that at home. Yeah, because if there's a local overload, we don't want the house to burn down. So we have built-in weak spots that would not be damaging really if this device responds. It is not costly, no problem at all. So we need to build in these breaking points. And we know that in complex systems, management science knows that very well. We need to have a modular design. And modular designs are extremely powerful. Just take Lego as a design principle. So you need to have many separate parts that can be put together in many different ways. I've learned a lot actually in a hackathon that I organized together with Swissnex in San Francisco about earthquake resilience. And we've kind of reinvented a disaster response in just a day. So disaster response is traditionally hierarchically organized, like a military organization. So there's somebody on top who would get information from the bottom, would integrate this information, would take decisions, optimal decisions as much as that can be done, and then give commands to the people below and tell them what each of them would have to do, and they would tell all of their subordinates what to do. Now, in many cases, actually, that doesn't work so well because communication is interrupted, information is not accurate, and all sorts of things go wrong. Now, what did these hackers come up with? They came up with a completely different system, and we'll come back to details later on. So their proposal was, okay, let's collect this information, what needs to be done, but then post that visible to everyone. And then people could say, okay, I can provide water, I have some fuel, I can help in the neighborhood, whatever, and in this way match demand and supply by combining top-down and bottom-up in a new way. In fact, as information systems spread, we see a trend towards decentralized bottom-up approaches. Decentralized approaches are known to be very efficient, for example, in the immune system. So nature uses it. But also, we now have peer-to-peer money and peer-to-peer lending, robot swarms, and more decentralized approaches even in traffic control. So we are entering a new era. There's a paradigm shift, a new way of thinking. And as systems become more complex, the components of the system need to have more autonomy in order to achieve the goals in the best possible way. So we need to go away from this scenario of over-regulation towards this scenario of self-organization. We need to have institutions and infrastructures that would support people in taking efficient decisions and actions. And in fact, sometimes self-organization works surprisingly well. And there is a reason for this. It's a design issue. There's unidirectional traffic flow in front, unidirectional traffic flow in the opposite direction in the back, and a buffer in between. And this buffer allows everyone to adjust the speed in such a way to find a gap when you need it. This is all. And it works so beautifully. In fact, the stream of socioeconomic self-organization based on distributed control is very old. And people still dream it. We know it from this book, Fable of Bees, 300 years old. Like the idea the society could work like a beehive, so well organized. And of course it shines up in Adam Smith's idea of the invisible hand. Unfortunately, the invisible hand doesn't always work. As we see for environmental pollution, also for the financial crisis, for many other problems that are just there. So, if it was really true that if just everyone does the thing that's best for him or herself, then it would also produce the best outcome for the world. Then we probably shouldn't have these kinds of problems. Overfishing is just another of these problems. But I believe that 300 years after the invention of the invisible hand, using the Internet of Things that is now emerging, we can make the invisible hand work. So we can run self-organizing systems based on real-time measurement and adaptive feedbacks. In fact, the Internet of Things is now spreading. We have more sensors than people in the world. In 10 years, we'll have 20 times more sensors than people. And we can solve problems like this one, like this annoying stop-and-go traffic that I've shown you before. So let's see what the problem is. Well, actually, there's some people who are trying to squeeze themselves into the freeway that produces small perturbations. The perturbations are amplified and produces stop-and-go waves. Now, assume we equip these cars with radar sensors that measure distances and relative velocities, and then the cars self-drive autonomously in a way that stabilizes the traffic flow and increases the capacity. This can be done. We have tested that with Volkswagen. So we can get rid of the problem of congestion, to a certain extent, with adaptive stabilizing feedback. And we can do similar things for cities. We can build smart cities. So let's compare 3 different ways of organization. Top-down regulation, bottom-up self-organization, and bottom-up self-regulation. Sometimes vary the names a little bit, but the main point is this is what we have today. So we have a traffic control center. It's trying to collect data from all over the city, then it's trying to come up with an optimal control, and that's then implemented in the entire city as it were a benevolent dictator. The problem is that you cannot do this strict optimization in real time because it's an NP-hard optimization problem, so you have to make simplifications. So you try to synchronize cyclical operations. Now we could do something else. We could say, okay, let every intersection separately, strictly optimize traffic travel times of all the cars approaching this intersection. This is not very difficult. This is what the Homo economicus concept would imply. Everyone, in this case, every intersection separately does the optimal thing. Would we get an optimal organization in the city? Third thing is, we also try to minimize travel times, but sometimes we don't. Sometimes we first reduce long traffic jams, long queues actually, of vehicles before we go back to travel time minimization. So what will work best? Let's have a look. So as we increase the utilization of the intersection and traffic module. We see that the top-down regulation comes with an increased queue length. Yeah, this is what you would expect. Okay. Now, how does the principle of Homo economicus, the local optimization, perform? Oh, much better. No? This is why markets outperform centrally controlled economies. But wait a moment, what's happening here? Oh, wow. Suddenly the queue length is exploding, coordination breaks down. Here, suddenly, the top-down control works better. But, so we can say that Adam Smith's invisible hand works here for small and medium traffic volumes, but it fails when we challenge the system too much. Turns out, though, that we can make the invisible hand work with this other regarding approach that reduces long queues before they reach the next intersection, before we get back towards travel time minimization. And altogether, it produces the shortest queue lengths of all these different approaches. And also over longer distances, it produces the shortest travel times. So, surprisingly, bottom-up self-regulation can outsmart optimal top-down control. If you have a sufficiently complex dynamical system, which is hardly predictable, yeah, unfortunately, more and more systems in the world are of this kind. So, that means we need more and more such an approach, a new approach to make the system work efficiently. And in fact, it produces wonderful self-organization patterns, green waves, and it's good for all the traffic participants. It reduces travel times for individualized traffic, for public transport, for pedestrian and cyclists. And it's also good for the environment. So it has only benefits, but it requires a completely different kind of thinking. Rather than have traffic lights control the traffic flows, you have the traffic flows control the traffic lights. Now the question is, can this principle be transferred to the economy and to the society? People would say a technological system is much easier to control. That's true. Yeah? But since Elinor Ostrom, Nobel Prize winner in economics, we know that it's possible. She has been studying self-governance in Switzerland. Yeah? She was studying Allmende. And she found that this was very efficient, given proper design principles. And she fleshed out these design principles. Now, one of these social principles that can actually promote quality and responsible behavior are reputation systems, and that's the reason why they spread all over the internet. And it's actually good for all sides. So customers get a better service on average, but sellers can take a higher price for their products if they have a higher reputation. So why don't we just apply it everywhere? Now, we can actually come up with much more sophisticated approaches, social information technologies that would help us in all sorts of situations, to avoid losses, to avoid exploitation, to improve fairness, to create win-win situations. And there are a number of these technologies that I've been thinking about and also patenting. And finally, we'd like to support collective intelligence. I mean, we need to bring the best ideas together, and information technology can help with us with this too. Surprisingly, it's not the best single person or best algorithm or computer that wins. It's a combination of several solutions, so diversity wins. And that's one of the major reasons, why this one huge supercomputer that would want to control the world wouldn't produce the best solution, because we need diversity. Diversity produces better solutions. Now, what do we need to do to prepare for this future world, to produce the data and information that we need, and to have this bottom-up distributed management approach that I've advertised, which basically, talking about our society and our economy, means more bottom-up participation. Well, this is where the planetary nervous system comes in. So, all it actually takes is you and your smartphone. Because we can connect these smartphones to build a global measurement system. Not just theoretically, we can do that practically. Each smartphone has about 15 sensors in it for luminosity, for noise, for location, for acceleration, and so on. So these are acceleration data, for example. The question is, what can we do with it? Now, just suppose one single smartphone shakes, and maybe it's just somebody who is riding a mountain bike. But if all our smartphones would shake at the same time, it would mean, oh, that's an earthquake. Yeah, it could warn the friends, family members, and colleagues in our contact list to give them a few extra seconds to get out of the building. Today, this is the universal survival kit. I actually think the universal survival kit of the future looks like this. And these are actually the proposals that the 3 winning teams of our Earthquake Resilience Hackathon came up with. Number 1, charge beacon. That means solar panels allowing you to charge your mobile phones even if electricity is down. If there is a blackout because the earthquake was there. So you could still use your smartphones. Maybe the central infrastructure is not working, but you could have your smartphones talk to each other through ad hoc networks, like Hummel is working on this. There's mesh nets, fire chat, this is how smartphones among each other could exchange information. You could also use your smartphone to take pictures of damaged buildings, bridges, whatever, make annotations, and you would upload this information as soon as you are in contact with other smartphones or the internet. And that would help actually the disaster response management team of the government, because it would get this information long before their people can be in all these places, so they get a quick overview. They can use their resources much better. They benefit from it, but also people benefit from it because they have good local information. They can also say, oh, I need help. I need baby food. I need some warm clothes. I need water, whatever. And other people would say, hey, I can help. I can offer this and that. So we just need an app that brings it together. And this is the third team that came up with this app. So basically, within one day, we had 3 solutions that all together create this survival kit for an earthquake. Isn't that amazing? Yes, but we need a system that we can trust. If we use our smartphone, open up these sensors, we want to trust this damn system. So how would we do this? Well, we need to be in control of the data flows, right? So we need to be able to turn each of them on and off, all these sensors. We want to be able to decide, would we use these measurements only for ourselves? Would we share them? And for what would we share them? What kind of applications would we allow? So that requires an open personal data store, basically. Whatever personal information happens to be produced about you, I'm not just talking about planetary nervous system, but also about all these companies that are producing data. I think everyone should send these personal data into a data mailbox owned by you, where all the data about you go in, and then you can have different categories of data, and you can say, okay, I'm happy to share my consumer data with companies of all kinds because I'm happy to get personalized recommendations, personalized products, and all these kinds of things. I'm happy to share my social contacts with my friends, maybe not with my grandmother and grandfather, and certainly not with the companies. Maybe you want to share it with the companies, but you decide, that's the point. Then what do you do with your health data? Probably you don't want to share them with anyone apart from your doctor, but maybe you want. I mean, basically, the main point is you're in control. You decide who can do what with your data, and it could also make money. So, just imagine to live in a world with 20 sensors per person. In each of the rooms that we're in, there would be sensors. We couldn't do a step, we couldn't say a word without this being recorded. If this kind of data would be owned and controlled by a single company, that could easily turn into a dystopic surveillance nightmare. I think the only way to run the Internet of Things in a way that is compatible with democracy is to run it as a citizen web. So we, as the citizens, would build this Internet of Things. We would use it, we would manage it together, to everyone's benefit. Like the principle of basic bottom-up democracy, as we have it in Switzerland, we just translate it into technology. And that would produce, we all together would produce an open data source, a real-time Wikipedia in some sense, a participatory system, so we all could contribute to this. And as you can see, working on this project is extremely exciting. And it's a lot of fun, so we can use it for gaming, for example. We can turn cities into adventures. There are no limitations because in contrast to an app that you would download from an app store, the app has pretty limited functionality. We would have a platform that allows you to connect outputs of these sensors with inputs and do all sorts of things with it that we could not even imagine. You could create your own games. You could create your own measurement apparatus for your scientific experiments, whatever, It's an open platform. And with a micropayment system, you could even create your own business and collaborate with others. So I think we should do this together. The success principle would be to give and take. And you can take data from this, real-time data. But you should also give data back because otherwise it doesn't work. And the same thing with codes. So open source is the idea. How we measure, what we do with the data. All of that requires algorithms. And if we share that with each other, then you can take our code. You have an idea, wow, I could change that, to adapt that to my own personal ideas and needs, and do something at home with it, whatever. Modify that together with your friends, upload it so other people can use it, they can modify it, and so on. So basically that creates an applications ecosystem very quickly, a powerful ecosystem. And so I think that would create really benefits for everyone, for citizens, for scientists, for politics, and for business. And it's not a dream anymore. We have started to do this. There's a small team of people working with me on this. And here's one of the experiments they did. So they came up with proximity sensors, so-called beacons. We use 3D printers to produce this. Of course, we want to be as self-dependent as possible. And then we distributed these beacons in buildings. My guys went to the Chaos Computer Club conference, and there they were actually giving these beacons to people. We took beacons because we didn't want to localize people. We didn't want to know who is it and where are they. We were just interested in interaction patterns, so anonymity was ensured. And many people were excited to participate in this, and you see 2 snapshots of this, which shows that the whole thing was actually working, right? So what could we do in perspective? Well, we could create awareness of our situation and of our impact on the world. Well, we could actually map the globe in 3D. Everyone can take pictures, and these pictures can be put together. And we can, from our desk at home, from here, we can reconstruct the world in 3D. Isn't that amazing? Mark Holliface from ETH has been involved in this. We can map environmental change and who causes it. We can map resources and who uses them. We can also try to understand the countries of the world better and their success principles. We don't know so little about these success principles. Did we know that we could combine them to create more successful socio-economic systems? So get ready. Take your smartphone out. Team up with your friends. And join the NervousNet community today, because we can improve the world together, and we can grow global like OpenStreetMap did. Thank you very much.